Have you ever looked up on a clear day and wondered, why is the sky blue? It feels like such a simple question. The sky is just blue. But the real answer is one of the most beautiful pieces of physics hiding in plain sight. It involves sunlight, tiny invisible molecules, and the way light bounces around high above our heads. So let's break it down step by step. First, we need to talk about sunlight. The light that comes from the sun looks white, or maybe a pale yellow. But that white light is actually a mixture of every color at once. You have seen the proof of this yourself. When sunlight passes through a glass prism or through raindrops after a storm, it spreads out into a rainbow: red, orange, yellow, green, blue, and violet. All of those colors were hiding inside the white light the whole time. The prism simply separates them so we can see them. So, if sunlight contains every color, why does the sky show us mostly blue? To answer that, we have to understand what light really is. Light travels as waves, and each color has a different wavelength, which is just the distance between one wave and the next. Red light has a long, lazy, stretched out wavelength. Blue and violet light have short, tight, quick wavelengths. This difference in size is the key to the entire mystery. Now let's add the final ingredient: Earth's atmosphere. The air around us is not empty, it is full of tiny molecules, mostly nitrogen and oxygen, floating everywhere. These molecules are incredibly small, far smaller than the wavelength of light, and when sunlight comes streaming in from space, it crashes into these molecules again and again. Here is where the magic happens. When light hits these tiny molecules, the light gets scattered, which means it bounces off in new directions. But, and this is the important part, not all colors scatter equally. The short wavelengths, blue and violet, get scattered much, much more than the long wavelengths like red. This effect even has a name. It is called Rayleigh scattering. Blue light is so small and quick that it bounces off air molecules far more easily, getting thrown all across the sky. So imagine sunlight pouring into the atmosphere. The red and yellow light mostly travels straight through, but the blue light gets scattered over and over in every direction, bouncing from molecule to molecule. That scattered blue light fills the whole sky, and no matter where you look up, some of that blue light is being bounced down into your eyes. That is why the sky glows blue. But wait, if shorter wavelengths scatter the most, and violet is even shorter than blue, shouldn't the sky be violet? That is a brilliant question, and there are two reasons it is not. First, the sun sends out less violet light than blue light to begin with. And second, our eyes are simply more sensitive to blue than to violet. Our eyes have special color detectors that respond more strongly to blue. So even though some violet is up there, our brain blends it all together and sees a beautiful blue. Now, this same idea explains one of the most stunning sights in all of nature: the sunset. During the day, when the sun is high above you, sunlight only passes through a thin slice of atmosphere to reach your eyes. But at sunset, the sun sits low on the horizon, and its light has to travel through much more air to get to you. Along that long journey, almost all of the blue light gets scattered away, lost off to the sides. What is left to reach your eyes is the red and orange light, the long wavelengths that do not scatter as easily. That is why sunrises and sunsets glow with reds, oranges, and pinks. It is the exact same physics, just a longer path through the air. This also explains a few other everyday mysteries. Have you noticed that the sky near the horizon often looks paler, almost white, compared to the deep blue straight overhead? That happens because the light near the horizon travels through more air, so the blue gets scattered and rescattered so many times that the colors blend back toward white. And what about clouds? Clouds are white, not blue. That is because clouds are made of water droplets, which are much larger than air molecules. When particles are large like that, they scatter all colors of light equally, and when all the colors scatter together, they combine and we see white. The same thing happens with fog and even with milk. Both scatter every color, so both look white. Here is another thought. If the sky is blue because of our atmosphere, what does the sky look like where there is no air at all? Out in space, astronauts do not see a blue sky. They see pure black, even when the sun is shining brightly, because there are no molecules out there to scatter the light. That is why the moon, which has almost no atmosphere, has a pitch black sky even during its daytime. And it is not just Earth. Other planets have different skies because they have different air. On Mars, the atmosphere is thin and full of fine red dust. During the Martian day, the sky often looks butterscotch or pinkish brown. But here is the twist. On Mars, sunsets can actually glow blue, the opposite of ours, because of the way that dust scatters light. Every world paints its sky with its own brush. So let's put it all together. Sunlight is made of every color. It enters our atmosphere and slams into countless tiny air molecules. The short, quick blue waves scatter far more than the long red waves, spreading blue light across the entire sky. Our eyes catch that scattered blue from every direction, and we see a blue dome above us. And when the sun sits low at sunset, the light travels farther, the blue is stripped away, and we are left with glowing red and orange. It is amazing when you think about it. The color of the sky is not really a property of the sky itself. It is a story about sunlight, tiny molecules, and your own eyes, all working together at the same time. So the next time you look up at that calm blue stretching from one horizon to the other, you will know the truth. You are not just seeing the sky, you are watching billions of tiny collisions of light, scattering blue in every direction, just for you. The sky is blue because the air takes white sunlight, picks out the blue, and sprinkles it everywhere you look. A simple question with a truly beautiful answer.